How many speed do you have and what is your ultimate speed?
Okay. Uh, this drill output is 1700 RPM. When we connect it, let's say, example, we connect it to a 17 teeth, and then we should connect it again to a 11 teeth. I'll show you here our power system. So, as the drill turns, it will be connected to one gear. Then each of these drill will have its own shaft, and that shaft will contain one gear, which is 70 or 16, and we will connect it to a main shaft, which is located here. This main shaft will have 11 teeth for each drill. So there will be 4 11 teeth sprockets, and there will also be one more 17 teeth here connected to another shaft, and this final shaft will be connected directly straight to the wheel. From 1700 RPM, it will increase up to 10,000 RPM at the wheel. And 10,000 RPM is, we consider it to be fast, but that is neglecting other forces like friction and gravity and whatever. So yes, we expect to come out with a maximum of 10,000 RPM at the end. Any other questions? Right. This has 260 ampere hour. For softwood drilling, it will last around 1 hour. And for this, since it will require more power output, we estimate it to come out with less than half an hour. Okay. The whole total cost, including shirts and whatever, will be less than 5,000. Yes. Because we found that we can actually save cost by buying one whole material and cutting it in place and then welding it instead of buying per feet. So this angle bar will come at a whole length which is 20 feet long, 6 meters, and we will just cut it into shape and weld it. So we actually save a lot of cost.
What program you use to draw?
Okay, I guess everybody wants to know this. Yes, this is actually Blender 3D. This software is for animation purposes, for 3D modeling and such. I know as engineers we use softwares like Autodesk Inventor. I think you've used it. Katia, SolidWorks. Yes, we've heard that. And those are much better when it comes to precision. When we want to build a certain part, component, and we want to assemble it. Now, for this purpose, as diploma students, we do not have the chance to learn such thing yet. And this program is what I've learned since I was young. So my experience in this software is up to par that I can do this. So I use this software which I'm comfortable with so far. Any other questions? Right. For this drill, we will actually connect it to a U-bolt. This is a smaller version. It's actually a bigger one, which will hold the drill in place, and it will be connected here. That U-bolt will be connected to this plate here. There will be holes here. Connect the bolt, and we will nut it in place.
How are you going to control all the 4 drills at the same speed?
Yes, as mentioned by my friend Vincent, we will use bicycle brakes, and that bicycle brake will be, we will actually attach it parallelly to a main plate, and that main plate will have one cable which would be directed at this bicycle grip. So the inside we press this bicycle grip, it will be attached to that main plate. That main plate will pull all 4 at the same time. So all 4 will run simultaneously instead of one by one. Any other questions?
What is the maximum
maximum weight. Yes, our driver itself is less than 50 kg. So it's, I think he's the most efficient for a driver. So we took a maximum of 50, just plus minus, for the driver weight. For the rest, for steel, including all the other materials, we take a maximum of 80 to 90 kilograms.
Loading? That's the maximum loading.
Yes, maximum load.
You and I cannot.
Okay.
So the driver, let's say 100 kilos, and the thing.
Okay. Since we use mild steel is a very, very strong material. It's cheap. It's strong. Although it's a little bit heavier than aluminium, yet it can support. Yes, it can support anyone higher than 100 kg.
Yeah. I mean your structure can support. How about the drill?
Okay. For the drill,
car move or not?
yes, the car will move, but it won't move at a fast rate.
So that means we already put our cart to set for a driver that is optimum weight is around 60 to 40 kilos to move at his most efficient speed. And I think that answers your question.
Okay, you see about the outlet.
Each drill for 1,700 RPM, it can go around 30 kilometers an hour if it is attached to an 18-inch wheel. Now this is a 26-inch wheel. It goes at an expected rate of 10,000 RPM. So freely, without friction, it can go up to 100 over km, 200 km per hour. But that is neglecting friction, neglecting power loss and whatsoever. With power loss and such, we expect it to go around 40 km.
How safe is this? Your brake system can take out speed?
Yes, our brake system will take the speed because we expect the driver to actually slow down before braking and stopping the car. So yeah, we're using brake disc. Brake disc is very, very powerful. So as compared to a normal bicycle brakes.
How long the battery and the power
For the whole cart, less than half an hour. So we have to actually maintain it as much as possible. Because less than half an hour, I think, yeah, the whole race itself, we don't know how long is the duration. So we have to maintain this battery, and because the battery will charge at a rate, fully charged is around 75 minutes, which is 1 hour over. It's taking quite a long time. So we have to maintain this. So we did have a plan for every maybe 10 or 15 minutes, go to the pit stop, change battery, and charge while he uses the other spare batteries. So it will take half an hour or so. 26-inch. It's quite big. It's a mountain bike wheel.